Hello everyone, in this video we are going to discuss how to simulate serial input, serial output. Here I have used 74LS 74DIC as a D flip-flop. You can also use D flip-flop itself. If you so go to place component and then enter D, right? Oh, sorry. So we have to go for all groups, then click D. So you can also use this D flip flop, but here I have used 74LS 74D. In order to get this one, you have to go for TTL and then enter that IC number 74LS 74D. See here, I have used this one, right? So click OK. So here I have a preset and clear. In that D flip-flop we have set and reset pins. In this IC I have preset and clear. Here I have not used these two pins. If you are required based on your application, you can use that particular pin. Okay, those two pins. So right now I'm not using these two pins. I'm using input, clock and output Q pin. Okay, so for the D input pin I have to assign um, here I have assigned 1. Based on your requirement you can change it, it may be 1 or 0. So here I have used the digital clock along with the ground. You have to connect it with the clock. Here we have to connect the global clock signal for all the 4 flip-flops. It is a 4-bit serial input, serial output. So we need 4 flip-flops. The output of the first flip-flop is connected as a input of the second flip-flop. The output of the second flip-flop is connected as a input of the third flip-flop. The output of the third flip-flop is connected as a input to the last flip-flop. So once if your circuit connections done, right, here I have used prop, right? So in order to see the waveform as a graphically, so I need this prop. In order to get this, you have to click and you have to paste it on the wire. Okay, so once your circuit connection done, and also in order to see graphical representation, go to simulate, go to analyze and simulation and transient and change to here stop as a 0.001 to 0.005. So click save, then run. So this is your transient response of serial input, 4-bit serial input, serial output circuit. See here, for the, as it is a positive edge of the clock pulse, the first flip-flop received the 1 input. Okay, so the second flip-flop received the 1 input, right, gives the result 1 as a 1 at the output side for the second clock pulse. For the third clock pulse, the third flip-flop receive 1 and it gives the result as a 1 at the output side of the flip-flop. The fourth clock pulse, the fourth flip-flop received the 1 and gave it results at the output at the fourth clock pulse. As it is a serial input, serial output, so for the first clock pulse, so we'll get the result at the first flip-flop. For the second clock pulse, we'll get the result at the second flip-flop. For the third clock pulse, we'll get the result at the third clock pulse, we'll get the result at the third flip-flop. For the fourth clock pulse, we will get the result at the fourth flip-flop, because it is a serial input, serial output. This is the graphical representation of our SISO. Thank you very much.